Good evening. Welcome to my talk, which is about Azure NetApp Files. Azure NetApp Files is essentially high-performance storage in Azure, and hopefully what you will see as part of this presentation is how you can leverage it to your benefit to improve performance and hopefully, ideally drive down cost. A very quick introduction to myself. I do this now because I did a talk last year and I was criticised that I didn't really introduce myself. I just waded into talking about the subject that I was there to discuss. So I've listened, taken the feedback, and ultimately here's a couple of minutes on me, who I am and where I come from. So I'm Anthony Mashford. I'm a cloud solution architect. I work for NetApp. I've been working within Azure for the last 10 years. Now, if you're familiar with the Azure platform, you'll realize that's a relatively long time in its lifespan. My background, however, is data centers. I've been in the industry now for over 20 years. However, this isn't my first career. My first career was actually working as a fisherman. So when I left school, 16 years old, I needed a job, and I got a job working on the fishing boats. And I got tired of getting up early in the morning and getting cold and wet. So then I entered into my second career, which is part of Her Majesty's Royal Marines, which is now His Majesty's Royal Marines. And quickly realised that I didn't figure out or didn't really think about that because I still had to get up early in the morning and get cold and wet. And if you're interested, that's me there. Now I'm in my third career. And as I said, I've been in this job now over 20 years. My role, Cloud Solution Architect at NetApp, I'm focused on Azure. Even though I work for and I'm paid by NetApp, I'm very much all about Microsoft and the Azure platform. I'm actually embedded within the Microsoft teams as well. So I work closely with my Microsoft colleagues and indeed the product group, feeding back information and everything else. So I've got a relative amount of experience, but really it's in data centers. I come from lifting heavy bits of tin in and out of racks, running miles and miles of cable. I'm not, say, a developer per se. I'm what you would say an admin. So on the DevOps coin, I'm very much the ops. I'm not necessarily the dev side of it. However, I took the decision around about 10 years ago to look at my career and figure out what I want to do, and hence why my journey then started to the cloud. Outside of work, I like having fun. Basically, that's me having fun. Motorcycles are my thing. Skids, wheelies, basically having fun on two wheels. A lot of circuit riding. I do a lot of road riding. I do a lot of teaching as well. So this evening's agenda. So what I'd like to talk about, really to start with, are the challenges and what Azure NetApp Files can bring to help fix problems or address the challenges you might be receiving. Give you an overview of the Azure NetApp Files service as well. And I hope you'll see that it's difficult for me when I talk to my colleagues who are, let's say, very traditional in their approach, where they used to put in boxes into data centers. The conversations I have now aren't with storage people. They're with DBAs, developers, people who just want to consume storage. They don't want to be managing it, okay? And I hope, again, you'll see that how Azure NetApp Files can go a long way to help you there. We'll discuss the performance, because really that was what Azure NetApp Files were born for, was to deliver high performance, low latency storage on demand. And I hope to try and give you a quicker demo and show you around the Azure portal, show you how to deploy that. Even though I openly put my hand up and say I'm not a coder, again, due to my transition and my adoption of cloud technologies, infrastructure as code especially, I use Terraform a lot. So if any of you are familiar with Terraform, I've got many examples now within my GitHub repo of Terraform code that I use for various types of deployments for ANF. Those are there to be shared, and I can, you'll see, even though I've actually, if you go to my GitHub repo, the presentation is there. There's even Terraform example where you can deploy a completely autonomous bespoke ANF deployment, which has got, I think, Ubuntu machines in there, which you can use to mount and test as well. And that takes around about 10 minutes to spin up. That's all there as well. I'll share those links with you afterwards. Cool. So the challenges, and I think this is key, and I think it's one of the reasons Azure NetApp Files was born. Previous to May 2019, when Microsoft released Azure NetApp Files, deploying file-based storage that required performance was a huge challenge. Most customers would probably need to, look at the costs. They've got dev test environments. There's a migration. They need to scale up or indeed down. The migration, I think, is key as well, because it's file-based services, the same as you would deliver it on-premise using either NFS or CIFS protocols. You can take those workloads, and I know in a perfect world, it's all about transformation, modernization, cloud native. But realistically, for a lot of people who've got contracts, data center exit timelines, maybe the application is that legacy, it's just going to die in place, but they need to move it. The ability to migrate as is key. However, Azure NetApp Files is a platform service. It's a very modern service. It's a REST API-driven service. So you can control it programmatically. The cost as well. I mean, anybody who's looking at costs and sees any cloud storage costs is going to go, wow, that's expensive compared to what I'm spending on premises. And yes, it is, if you look at the bottom line. However, if you look at it in a round, look at the total cost of ownership, what it actually costs you to host that storage, power it, cool it, manage it, feed water it, maintain it, all of a sudden, the TCO does start to stack up. The bottom line's expensive, but actually the overall ownership of that is much, much more flexible. You can build it when you need it, you can destroy it when you don't. And again, hopefully you'll see some of the flexibility. And in the dev test world, which I'm guessing probably talking to most of the people in this room who are working in dev test environments where they need to create, applications, maybe that's using backend data. A gentleman I spoke to earlier was talking about containerization and Kubernetes. Azure NetApp Files has a really good meshes around that as well. One of our most prominent use cases is indeed Azure Kubernetes service. And NetApp as a company, we have our own storage orchestration for persistent container data called Azure Trident, which is, again, this is an overlay management, which is, goes a long way to helping with those costs, because when you need something, you deploy it either by a DevOps pipeline to push the code out to build the infrastructure, and when you finish with it, you destroy it. It's as simple as that. You haven't actually spent all that money up front, you just pay for what you use. So optimization of compute to meet demand. This is where it's important. So previous to May 2019, when Azure NetApp Files was released, you would probably, if you needed file services with Azure, you probably need to stand up either NFS cluster or scale out file services and Windows within Azure. Now that could be expensive, because to get the performance, you probably need big machines. Big machines cost money. To get the IOPS and the throughput, you probably need larger disks, more machine size, more disks, the costs just start to escalate. And also the performance wasn't very good. It was a huge, huge challenge. I was working on a project with a particular customer that had a legacy application which was written in the 90s, but it was the lifeblood of their company. It's how they earned their money. They needed it. They absolutely lived and died for it. They also needed to move out of the data center to Azure, so they needed to do a lift and shift. And it was challenging because they had clients that were consuming the service that they were giving them. And it was slow, it was unresponsive, it was unreliable, and it was causing huge, huge problems. I was actually involved with the migration of that customer from what was then scale-out file clusters, many of them, which were very expensive, onto Azure NetApp Files. And we did a whole, how much is it going to cost? What's the likely TCO? What's the return on your investment, etc. We estimated around about 90,000 euro. By the time we'd actually finished the migration and they'd be actively running for a year, they saved over 240,000 euro in 12 months. But the most important thing is the instantaneous, as soon as they went live on the new platform underpinned by ANF, no more customer problems, no more calls to the help desk. Even the customers were saying, what's happened? It's so much better. So the customer, our customer, their customers benefited. Huge performance increase, huge, saving on costs. So that is a really, really important thing to point out. And as I mentioned, this can affect the following by doing this: performance, scalability, costs, and also licensing. The scalability, to scale a virtual machine, you need in Azure. Sorry, I should have asked this. Hands up, who's familiar with Azure as a platform? So there's a few people. Yeah. Not too dissimilar, I guess, into AWS and GCP, but ultimately you've got machine SKUs in Azure, and they are sized by CPU, RAM, capabilities, throughput, etc. So you need bigger machines to get performance. The ability to scale that, to create or to change the SKU of a virtual machine, you need to restart it. So you've got downtime to factor in. Also, the cost starts going up, and licensing as well. The example around licensing is, say you're running SQL on the box, not Azure SQL, but SQL on infrastructure services within Azure. To get the throughput, to get the I/O, again, you need those bigger machines, larger, faster disks. The cost really starts to ramp up. And also, because you need the larger machines, they're going to have a higher CPU count, and in SQL, depending on how you license it, that could be costly as well. By decoupling the storage from the machine, all the processing, all the I/O is taken care of by Azure NetApp Files. Therefore, you can run smaller machines, saving on the VM SKU, saving on the licensing, much more dynamic as well. And Azure NetApp Files, as you see, can be scaled up or down on demand. There's no limitations. So, talked a bit about it, but Azure NetApp Files, let's get to the point. This is really key to understand. It's a Microsoft first-party service, supplied, supported, and built by Microsoft. It has NetApp's name in it, but it's a Microsoft service. It's underpinned using NetApp's technology, so the hardware and NetApp software. And I think that's also really important. It's the only first-party storage service in Azure by a third party, if that makes sense, by a vendor. Because of that NetApp lineage, that NetApp history, NetApp has been in business over 30 years. They have a history and a pedigree of delivering high-performance files. My apologies, a death grip on the microphone. Yeah, so that is a really key thing to understand. The use cases where Azure NetApp Files can really add value. There are 6 or 7 key use cases, but ultimately, where file services are required, where performance and latency is required, that's where ANF can add value. One of the biggest ones is SAP. If anybody's familiar with SAP, it's very highly strung, very low latency sensitive, needs a huge amount of throughput performance. Azure NetApp Files is the only storage certified in Azure to run SAP S/4HANA. And if you understand S/4HANA and how finicky and problematic it can be if the performance isn't absolutely there, then you'll understand what ANF can actually deliver. One of the biggest ones as well, aside from SAP, is VDI workloads. So Azure Virtual Desktop, either driven by Citrix or native AVD. The ability to host those user profiles and present them to the session hosts. Again, decoupling the storage from the session host or from the machines themselves, and the ability to scale as well. One of the most recent ones, which was announced by Microsoft in November last year, is Azure VMware Solution. Again, it's one of these strange ones. When I first heard about this, well, why would you want to take virtualization technology, put it into a public cloud on top of what essentially is another virtualization technology and do exactly what you would want to do, or what you're going to do in your own data center? But it does have its reason. There are very good reasons there. Skill set primarily. Companies who've been running on VMware for many, many, many years, where they've got staff with huge amount of experience and knowledge around the VMware platform. Data center exits, time to lift, time to actually move, no time to modernize. And I'm pretty sure a lot of people in this room will understand do you flinch like I do when you hear, let's modernize something, let's make it cloud native and everything else, and does it work? I've done one, I think. I've been involved with one project in several years where actually there's been an active migration for rewriting an application, actually delivering into a cloud native solution. It took 3 years to do that because it, again, was the lifeblood of the company, and they had to make sure, but it was an extremely well managed, extremely well run project. It had its pitfalls, but we got there. But realistically, companies moving out of their data centers, out of on-premises, be it the broom cupboard or Rackspace or wherever else, it's probably going to be a lift and shift. And ANF goes a long way to unblock that. The AVS solution, Azure VMware Solution, is the ability to do that. So you can deploy and run native VMware solution within Azure. It's a HCI solution. So a HCI solution is essentially compute, RAM, storage in a box. If you need more of anything, you need more boxes, and those boxes aren't cheap. What the ANF solution with AVS is NFS data store support. So you can, again, decouple the storage from the HCI nodes and consume Azure NetApp Files as an NFS data store for the VMDK files and everything else, so you can grow that storage independently. But again, you've got that high performance, low latency. Other workloads, Kubernetes, Azure Batch. I've actually got a very large customer at the minute, probably UK's biggest online retailer, who are running Azure Batch with ANF. They've moved off of what was a IaaS-based storage platform. The reason they were on that is because when they deployed back in 2018, there wasn't an option. I had to go with what was there. It was costly. It was okay. Performance was okay. It wasn't great, but they said it was okay. It was the business could tolerate it, but it was proven to be really, really expensive. They are now actively migrating, and they probably have finished by now. But straight away, the batch processes which they run on a daily basis to do with all their procurement and ordering systems were taking approximately an hour and a half to an hour and 45 minutes to complete. As soon as they moved to Azure NetApp Files, same storage as in capacity, but the improved throughput, those batch processing times dropped by 50%. And more importantly, they're now saving hundreds of thousands of dollars a year because of moving off of the conventional storage, file storage, onto ANF as a platform. Another one which I've been quite heavily involved with is high performance compute. Several universities I've been working with, they use HPC for various modeling, and 2 Formula One teams. One of them, actually, I did help write the Terraform code to deploy in their CI/CD pipelines. They didn't finish very high up in the Formula One championship. I'd like to think that's not down to me, but yeah. So it does have many, many use cases. Even right down in the bottom of just standard file storage now, we're seeing it. I'm seeing quite a few customers, and I'm speaking to a few. I actually spoke to one today. Application developers are needing just dumping grounds for the data, but there needs to be a file path. It could be seen as expensive because it's all around high performance, low latency. But I feel the brilliancy of Azure NetApp Files is the simplicity of it. You can deploy it very, very easily via the Azure portal. Likewise, programmatically using a REST API, and that can be ARM templates, Bicep, Python, Java, many, many methods you can employ to actually, manipulate it. But the simplicity makes it attractive because, as I said earlier, I have to remind some of my colleagues who come from, let's say, a more conventional background that you're no longer talking to storage admins. You're talking to people who just want to consume the storage. And it's becoming quite a popular option as well, just to simply create the storage, present it to the host, that's it. Microsoft take care of all the management for it. You just tell them how much you want, how fast you want it to be, and where you want it to be. So those are some of the use cases. So the actual performance side. So overview, widest choice of protocols within Azure, NFS versions 3, 4.1, indeed SMB as well. The SLA is important to take note of as well. Azure storage has normal Azure storage, conventional storage has 99.9 SLA. Azure NetApp Files, 99.99 SLA. It does bring that on-premises class performance, as I mentioned. The ability to take applications that you've been running within data centers for years that have that super low latency requirement, performance requirement, high write read requirement. And it is that consistent experience, as I said before, supported, built by Microsoft, all through the Azure portal. It's not marketplace. Yes? Service level agreement. Yeah, so basically that's the uptime, the availability time. Azure NetApp Files currently has 3 service tiers: standard, premium, and ultra. So at the standard tier, you can realize 16 megabytes per second of throughput per terabyte, right up to the ultra service tier, which is 128 megabytes per second per terabyte. These can be flexed independently as well. So as an example, if you were running batch jobs that's done once or twice a month, what you could do is you can actually host your storage on the standard tier. And then once your batch jobs are coming up, maybe 12 hours prior, you can simply move those volumes up the tier to gain more performance. However, there is a caveat. There's a 7-day cooling off period, but ultimately, you can then move your storage back down to a lower service tier and save the cost. So it does become quite compelling. Within the same service tier, you can flex your volumes, size, or throughput independently as much as you want. And I'll show an example of how that differs to other Azure Files offerings within Azure. So if you're familiar with Azure as a construct, you have a subscription. Okay, so a subscription is, imagine it's like your cabinet in your data center where you're going to put your stuff. Underneath your subscriptions, you create your Azure NetApp Files accounts. Now, the accounts is where you pin to geo, to region, where you need to deploy. When Azure NetApp Files was first released, I think it was 11 regions. I think we're now in well over 40, and Azure has around about 56 regions now. So around the globe, we are more or less in every single important region that's most important, probably the people in this room anyway. So yeah, you can have up to 10 accounts within a single subscription. Then you create your capacity pool. Now, the capacity pool is important for two reasons. It's where you set your performance tier. So you create your capacity pool, you say, I want it to be on the premium service tier. The sizing of the capacity pool at the minute is minimum of 4 terabytes up to 500. The really important thing is that's when the billing starts. So as soon as you create your capacity pool, you will be charged. And it's the usual per minute billing, but it's important to take note of that. Minimum of 4 terabytes, up to 500 terabytes per capacity pool. Within your capacity pools, then you place your volumes. Volume size at the minute can be 100 gig up to 100 terabytes, and you can have up to 500 of those. So ultimately, within a single account, you can have up 12.5 petabytes of storage should you need that. And you know, those are soft limits. Microsoft won't say no. If you want to spend more money with them, those limits can also be raised. Any questions before I continue, or is it making sense? Is there anything I've only seen so far that piques your interest? I thought, well, that might help me in my daily job, or no, nothing yet. So the performance side of it, how you would size that. Simple equation is service level times the volume quota where you get your performance. And the example you've got here is a 10 terabyte volume at premium tier, 10 times 64, 640 megabytes per second of throughput per terabyte is what you could leverage from the volume. Now, the original deployment of Azure NetApp Files was using AutoQoS, which meant if you needed more performance, you needed a larger volume. Not great, that really. In June 21, Microsoft introduced Managed QoS, which is much, much more flexible. So ultimately, within a capacity pool, the example you've got here, a 10 terabyte capacity pool at the ultra service tier, 1280 megabytes per second of throughput per terabyte. You can then independently assign that 1200 to the volumes within the capacity pool, independent of size. So a much, much more flexible solution. One method as well we do have to help solve the cost issue and really start to work with cloud economics is what we call dynamic volume shaping. As you see on the left here, the top line essentially is the provision storage. The blue line is the workload as it fluctuates throughout the working day. With dynamic volume shaping, you can again use this programmatically to flex those volume sizes to gain the performance as you need it throughout the day. An example of where you might use this, again, batch processing jobs, when you know they run at a scheduled time and everything, you can then flex it or grow it. Our VDI environment, user login storms in the morning when everybody's coming to work, say 8 to 10 a.m. You can flex the storage to make sure the performance is there. And as the performance tails off, you can then shrink it back down again. And ultimately, that then can introduce some cost saving. As an example, other Azure Files, other file storage offerings within Azure is a service called Azure Files, which is a great service. It's a first-party service from Microsoft. It does have some limitations, and one of the biggest ones is its flexibility. An Azure file share can scale up to 100,000 IOPS. If you need more performance, you need to create another file share. If you create another file share, you then ended up over-provisioning storage. And the other thing to point out as well is you can't flex that storage. If you grow a file share, you then have to wait 24 hours before you can cool it. It needs to cool off before you can then shrink it down again. So it's nowhere near as flexible. It's you do get burst I/O, but it's chargeable. Azure NetApp Files, you pay for what you use. There's no hidden charges. You simply choose the service tier, create the storage, and you pay for what you consume. Authentication as well. So for SMB SIF shares, you need to leverage Active Directory for authentication. With ANF, it's a simple line within the portal, or indeed, a simple command within the code deployment. It's important to point out as well, it's a private service, this. It has no public endpoint. The Azure storage services have public endpoints. Now, if you're going to deploy those within your own infrastructure, you need to lock those down. That needs to be taken into consideration. Azure NetApp Files doesn't have a public endpoint. You can only access it via a VNet. And it's a service which is delegated. It's a if you're familiar with Azure Resource Managed Service, which is what the resource manager is, the control plane for Azure, is hooked into a customer's infrastructure via a delegated VNet, which brings it into that VNet, and that's how it's accessed. No public endpoint, don't need to lock it down. With the other Azure Files offerings, it's complex. You need to go through all the lockdown of those public endpoints. Also, if you need to hook it into Active Directory for authentication, it's not straightforward. It's relatively complex. You need to be relatively comfortable with PowerShell, to the point that Microsoft actually put a video on the website to show you how to do it. So the flexibility and simplicity of Azure NetApp Files can be quite compelling. Don't get me wrong, these other storage offerings are very good. They have their place. But when you compare them to INF, they do have some shortcomings. One feature which has been around for a while now is what's called cross-region replication. So with Azure Storage, Azure File Storage, you have different storage SKUs, one of them being ZRS. But there's no way with Azure Files to replicate to another region. So if you needed to implement disaster recovery or the business requirements for resiliency, you would need to factor in some sort of file copy process, which would then introduce network bandwidth charges, and they can all start to escalate. Azure NetApp Files, as the name says, it's built on NetApp technology. So in NetApp technology, we have this replication called SnapMirror. What Azure NetApp Files has available is what we call cross-region replication. It's the ability to replicate a volume to a different region. It's an asynchronous copy as well. This isn't a synchronous copy. And therefore facilitate disaster recovery. As soon as you need to invoke DR, it's an instantaneous switch from read-only to write. And the replication intervals can be 10 minutes, 1 hour, 1 day. So it's a really great way to protect cross-region. For those who use Azure, do you use multiple regions? I'm seeing a lot of customers at the minute reverting to using single region with zonal protection. Right. Yeah. Yeah. So essentially the UK geo, but using both the regions. They're not crossing geos, so to speak. No. Okay. The way that cross-region replication works, it has regional and non-regional pairs. So to your point, in the UK, UK South, UK West, Europe, North Europe, West Europe. There are some Azure regions. France doesn't have a pair. So for cross-region replication, I think they use Germany West Central. And there are some non-regional pairs as well. So I think get this right, I think it's Germany West you can replicate to the UK. And there's a few again, right? But you can ultimately protect your data by creating that copy. And the great thing about this, because it's NetApp's technology, it's not file level copy, it's block level copy. It happens all within the service. So you haven't got those additional network charges if you were doing a file level copy across a VNet peer. Yeah.
Was that IOPS and size scale in that way, or was it just the IOPS?
Yeah, no. So basically, if you needed more capacity and there's capacity, if you needed a larger volume and there's capacity in the capacity pool, you just grow it. I'll show you that hopefully in a bit anyway. And likewise for the throughput, if there's the capacity throughput within the capacity pool, you can assign that to the volume as well. But also, like I said, you can move the volume to another capacity pool at a higher service tier should you need that, but there's that 7-day cooling off period to be aware of. Cool. This has got a new one. So availability zone volume placement is currently in public preview, which means Microsoft have exposed it to the public to utilize, to test, but it's not recommended for production. I think I did touch on it, but Azure NetApp Files 99.99 SLA. Unlike other Azure storage offerings, it's not a zonal aware service. So if there was a zonal failure, you could lose the storage from that zone. There are ways to protect against that, and but this is a new thought process or new mechanism to enable us to protect against that as well. So the availability zone volume placement is part of the volume creation workflows. When you build a volume, you can select the zone it goes into. If you're not familiar with Azure zones, essentially they are physically separate data centers. So if there's a catastrophic event within the data center, there's other zones are available. So the example in UK South has 3 zones, UK West doesn't. So that's another little thing to be aware around Azure architecture, that you can only use zonal protection within the UK South. But ultimately, you can choose which zone you place your volumes into. And then you can use application redundancy, to manage the data and the copy between that. The next one, they kind of go hand in hand together. So we talked about cross-region replication, the ability to replicate to a different region. This is a new one as well. It's released in December, and it's still public preview. It does go hand in hand with availability zone volume placement. Cross-zone replication, the ability to replicate your data across zones. So that's an automated replication based on a 10-minute, 1 hour, or 1 day interval, where it replicates your data into the second zone or the zone of your choice. And again, it's block level replication, it's not file level replication. So there's no charges for the network transfers, which can be, that's an interesting one actually. If anybody's familiar with Azure and Microsoft's threat to introduce zonal replication charges for the last 5 or 6 years, the date's always the 1st of July, and it always changes about a month before they put it to the next year and the next year and the next year. But they're going to do it at some point. At the minute, there's no charges for interzonal replication. They say it's coming, and I think the first time I saw it was 2017, I think. It's 2023, and I looked the other day, and it says 1st of July 2023, we're going to introduce zonal charges. Another one of those little gotchas. But the charges can be substantial as well. I know where we did, was involved with a customer where they had to migrate to one region, and then they needed to copy from one region to another. It was a file level copy. 300 terabytes cost about £7,000 to replicate across that line. So it's substantial things to be aware of. Yeah, there's little gotchas, these little hidden charges. If you're familiar with Azure Storage as well, like Azure Files storage are the premium tier, includes transactions. There's an Azure Files transaction optimized tier, which is slightly cheaper and factors in the transactions. A lot of customers say, oh, we can use Azure Files hot tier or cool tier because it's cheaper. It is, until you start looking at how many transactions and how much they cost. And if you look at Microsoft's documentation, there's something like 40 transactions they'll charge you for. And they read, write, copy, paste, delete, all those sort of little file operations that happen. And I've seen a few horror stories where customers are expecting £1,000 at the end of the month and they got 6, because of these. So all those little tiny things that gotchas within Azure. Regarding architecture is great, but you've also got to factor in thinking about the costs and how it all works. So yeah, so cross-zone replication only released a public preview in December, but really important, again, driven by customer demand. Another cool feature, which a lot of people don't seem to be aware of, is still in public preview at the minute, but it's the ability to run backup. So you can actually, there's an inbuilt backup capability for the service. So you don't need to invest in a third-party backup product. You can simply leverage it as part of the workflow. You pay for the storage that it consumes, but you don't pay to use the service. There's no licensing or nothing else. You simply consume it. What this does, within Azure NetApp Files, you have the snapshotting capability, which is, again, one of NetApp's USPs. So you can create snapshot policies to create the snapshots as you need them, set the retention policies around the snapshots. And then on a daily basis, Azure NetApp Files backup comes along, it hoovers up those snapshots and puts into essentially what is ZRS storage in the back end. So this whole backup strategy of having multiple copies of your data on different media. Obviously, you're running live with Azure NetApp Files. The snapshots reside in the volumes on the service. The backup service comes along, captures those snapshots and puts them in ZRS. And as an example, you can set your policies how you need, when you need to do, and the retention as well. So that is a really, really key service, which is proving popular, especially for customers that are running containerization. And that customer mentioned is running a batch, because what they're doing with ANF backup is because of the type of data that they host in the volumes, it doesn't compress well for the snapshots. The snapshots are relatively large, and that's obviously driving up the volume sizes. So what they're doing is they work with their business around the requirements the business has for RTOs and RPOs. So they're limiting the amount of snapshots they keep within the volume. ANF backup comes along, hoovers them up, then moves them. And that's helping them manage those costs, but maintaining the service they need to deliver to the company. And one thing they told us when I spoke to the chap who's running it last week as well, they can more or less now instantaneously recover from these snapshots to the point where you've got single file restore as well. So they can come down, recover the files, and they're just over the moon because it's just improved their operational efficiency much, much more. And hopefully there might even be a use case at some point. What I've also done, I said these slides are available. So if you want to reference them later date, there's a link on the GitHub. The presentation will be there. There's a few examples of the differences between Azure Files Premium, and obviously Azure Files. Azure Files Premium is the go-to for performance and everything else for file shares. Azure NetApp Files is a level above that. And I think in comparison-wise, the three service tiers that Azure NetApp Files has, Standard, Premium, and Ultra, they obviously have price points. And the Azure Files, Azure Premium Files, kind of falls in between the standard and the Azure NetApp Files Standard and Premium tiers for price. However, what we found, and I've done this with a few customers, is people tend to look at the name Premium and say, oh, they must be the same. But they're markedly, they're just so different. Azure NetApp Files Premium vastly outstrips Azure Premium Files because of the performance and everything else. Yes, it's more expensive, but the Azure NetApp Files Standard service tier can deliver the same performance at a much cheaper price point than the Azure Premium Files. So it's, again, when you're looking at file storage options, it is getting ridiculously complicated. You need to really start drilling down. But if you want to understand how you can drive the best performance and bring back good cost return, it's time well spent. It really is time well spent to understand that. Okay. Another one, the storage comparison. I think the big headline, especially for Azure NetApp Files, is 450,000 IOPS. So we can deliver up to 450,000 IOPS performance. Whereas I think I mentioned earlier, with Azure Premium Files, you got 100,000 IO per share. If you need more IO, you need another share. Another share is over provision of storage. So that is one of the big headline figures to take note of. Cool. This is where I start to cross my fingers. I'd like to just do just a very simple demo. I'm going to have to try and juggle microphone and keyboard and everything, but I'll figure that out. Ultimately, what I'm going to hopefully show you is, in true Blue Peter fashion, I have created something earlier just in case. But what hopefully I can also show you is how simple it could be. And I'll just talk you through some of the. Are people here familiar with Terraform? I'm going to make an assumption as a reasonable amount of people familiar with the Terraform tool. And I'll talk you through my awful code. Okay. My code is less than elegant, so I know I'm talking to some very clever people who probably spend a lot of time and they've got very good work ethics and everything else, but it is what it is. It gets the job done in my world. So yeah, I'll try and talk you through that, so just give me a second. Okay. Don't want that one. One decision I made about 18 months ago was to move to a Mac. I love Mac, but I hate it in the work environment. Don't know what anyone wants to do about it. So start with Azure, okay? People familiar with Azure Portal? Seen it before? Probably some people. If you're not, this is an Azure. This is basically a subscription. I'm lucky enough. I'm a Microsoft MVP, and Microsoft are very generous. They give us Azure consumption to use throughout the year. So this is what I use. I use it for my testing, presentations, and stuff like that. And that's what the MVP community is all about. It's all about supporting the community, helping people out, sharing knowledge. And very lucky to have this. It's priceless. So what we've got in here, this is my sort of little lab environment which I run. There's various things. These are resource groups. So a resource group essentially is a dotted line around resources really you put your stuff into. What I've also got in here, I'll just switch to this tab. These are two resource groups, and this is part of the code which I've created for this session. So if you wanted to go off and play with Azure NetApp Files, I will just find my, if I just get my GitHub repo. Again, apologies, I'm far from a coder, but I'm doing my best to adopt the cloudy world. There's some repositories on here. There is one created especially for this session. And in here, there's a presentation folder, there's a Terraform folder, and I've done a little bit of a write-up down here if anybody wants to go and play, essentially what you would need. So I use Visual Studio Code as a tool. There are many others out there. I also use, obviously, you need various plugins, and they're all mentioned in here. And essentially what it will deploy, a bit of a schematic of what it would look like in Azure yourself, and then there's just a very basic walkthrough of how to actually push the Terraform code. It's quite simple, really, to be honest. It's not rocket science. But I think What I've tried to do with the lab that I've put together here is to make it as simple as possible, but hopefully highlight some of the stuff which is already there and how simple it can be. I think that takes about 15 minutes to build. I did it manually. It took me 2 hours. So again, I'm probably preaching to the converted infrastructure as code, but that's really, really important. And some of the features that are in there are also just to highlight some of the capability. So let's have a quick look. So this resource group's in North Europe. The resources we have in here, capacity pool, volume, network interface card, because this is a network attached storage. So when you create your first ANF volume, it will create a network interface card. By the way, anybody who's got OCD like me and likes everything has to look the same, the naming conventions, even case, you can't control the name of that. It's annoying to customers. It is what it is. Get over it, right? But I do. I like, Azure has this little trait. Now, I don't know if anybody else who works with Azure has seen this. Even though you name everything lowercase, it will randomly put some uppercase stuff in there. Drives me nuts. It really does. So yeah, I'm also using an Azure Key Vault. Again, around security and making this as easy as possible. Terraform code creates a key vault, creates the secrets. It's also, I'm using the Terraform resource provider random string. So it creates a random string, makes the secret in the key vault, and that's what I then use for all the username and passwords to log into the machines. In some case, I'll show about that in a minute. Network security groups, again, this is network in Azure concept. Public IP address, I've created a Linux machine, which I think is Ubuntu, pretty sure it is. Disk on the machine, and then the virtual network is going to reside. So that's one half of it, and obviously that's reflected on the other side, because there's North Europe and West Europe, and then this cross-regional replication. And if you wanted to do any fiddling around the testing, mounting volumes, testing performance, etc., then this will take about 50 minutes, and you've got a nice little lab to play with. Okay, so let's have a look at the ANF account here. So this is your Azure NetApp Files account. I don't know why it keeps doing that. Quite basic, really. As I mentioned earlier, this is where you set your region, so where you want your data to reside. So UK South, as an example. This one is North Europe. Within the actual ANF account, the usual role-based access control, Microsoft also include this little gotcha for the quotas, because there are some quotas. A lot of these are soft, I think. The default quota for a subscription is 25 terabytes. That's a soft limit. You simply raise a support request to Microsoft so you can have some more storage, please, and of course, they're going to say yes, because they want you to spend money. But there's a couple of little gotchas around quotas. The properties are quite useful, especially things like resource ID. So when you're doing any IAC stuff and you want to call on a resource ID, you can find that from there. Obviously, Azure resource locks, goes without saying. Those who are familiar with Azure, apply to resource locks, prevents things like accidental deletion, etc., etc. The Active Directory connection. Now, I do actually have part of my lab, AzureTechLab.com, that's mine, and I do have an Active Directory connection string in here. So what that does is when I need to create a SMB volume, it uses this Active Directory configuration string to create the volume, which then creates a computer in Active Directory, which then leverages the NTFS permissions. You don't need that, obviously, if you're not using AD, and the lab, your lab, when you deploy it, if you deploy it, won't have that. That is just something that I have in that region already. The Active Directory connections is limited 1 per subscription per region, if that makes sense. And because I already have a North European deployment, which has that, that's why it's there. You won't see that in your lab. Encryption, obviously the encryption keys. Capacity pool. Again, as I said, the capacity pool, this is really important because it's where you set your performance tier. It's also where the money starts. So I build my labs and I destroy them quickly because it costs money. And I've only got a limited amount of money and I'm not going to use my credit card. So build it, you can use it, build it quickly, test it. And then if you're familiar with Terraform, you just run the destroy. It uses a state file and it rips it all down afterwards. So it's quite easy to play with. I've got a 4 terabyte capacity pool, standard tier, mine set to auto QS. It's quite simple. Then in here, hopefully, you should see a volume. So I've created my volume, and this volume is an NFS volume. Again, I wasn't planning on having the SMB stuff because it makes it complicated to put it into the lab for my Git repo, because you would then have to have a Active Directory configuration. So it's easy just to stick with NFS. But this is the volume, it's 1 terabyte, 16 megabytes per second of throughput, NFS version 3, and this is the mount path. This is where it gets quite cool because Microsoft, this is the as a service piece. You see, you don't need to think. If you needed to mount that volume, you simply go into the volume itself, and Microsoft will include mount instructions. They'll even tell you the packages that you need to install on your Linux operating system, be it Debian or SUSE. And then there's the you create directory, choose the, if you have multi-home machines, not recommended, but you can, choose the IP address you want to associate it with, and then there's the mount path. So you simply copy and paste that into your host. For an SMB volume, actually, I think I might have an SMB volume. Show you the same. Yep, there we go. So this is an SMB volume. With an SMB volume, if you're familiar with UNC path, it's a UNC path. Again, this here, so the first part of that, the prefix, ANF, that is what I've dictated. That's part of the Active Directory configuration setup. So, because that is actually a host as part of the back-end system, but the rest of it is randomly generated. So, get over it. Some customers really don't like that. So essentially, you copy that UNC path, either deliver it to your host by a code or batch job or manually, and then you've got your volumes mounted. Cool. Here. Snapshots as well. We haven't really talked about them in it. Snapshots are snapshots. Everybody familiar with what a snapshot is, or the construct of a snapshot? Yeah. And the great thing about snapshots, especially with Azure NetApp Files, is they're extremely lightweight. The way that the NetApp technology that creates the snapshots essentially just creates pointers to blocks on the disk. So they're extremely, extremely lightweight, depending on the type of data, obviously, and how it compresses and everything. So you can create your snapshot policies, apply them to the volume, and then more or less instantaneous restores. Or you could actually take that snapshot and create a brand new volume as well, should you. And you can also reverse a volume from snapshot. So extremely powerful. The backup we mentioned, I haven't got any backup. I'll tell a lie, there are backup policies. Interesting. So there are some backup policies configured in here. And the simple, if you wanted to restore these backups, you simply say restore to new volume or restore files. You can actually do single file restore now as well. If you know the file path, you just simply select restore files, put the file path in, and then it'll put it back where it was. So extremely flexible, very, very quick to do. You know, I'm guessing a lot of you guys work in an environment where you're probably reliant on admins to do stuff, or are you quite self-sufficient with self-provisioning? Depends. But how cool is it just to be able to go and do your stuff yourself without phoning Bob on the help desk and he starts sucking his teeth and say, "I can get it done next Wednesday," you know? And all because this is all role-based access as well. You know, whoever runs your systems within Azure, they are not going to want you doing stuff. But as long as you can convince them that you just need the permission to do stuff, they can create a custom role, delegate your permissions, and give you access to do what you need to do. What's the other thing I was going to show you as well? Oh yeah, the key vault. Just dive back here. So as part of this lab, what I've got going as well is there's an Azure key vault. Basically, Azure Key Vault is somewhere to store your certificates, your secrets. So the code actually builds within the Key Vault. I've got created a secret. I call the secret lab admin, and there's a reason for that. Because to cheat, I'm using lab admin as a username to log into the machine. And you'll see from the Terraform code, I pass the username of lab admin because it already exists. And what it does, it then pulls the encrypted secret out and uses that as the password to access the machine. And I know you should probably use SSH keys, and I always would use SSH keys, and you can use SSH keys. I ran out of time to get this built. So I needed to, it needed a bit of brain power. But if you're connecting especially to Linux machines and SSH all day, don't use passwords, plain text, etc. But this is a lab for playing with. Yeah. So in here, this is the secret. The great thing about this as well is, you know, you can store your secrets. If you've forgotten what they were, you now have the ability to actually make them visible. So you can actually visualize the secret, or you can just copy it, take it to your machine, and then log in. Okay. Any questions so far? Again, I realize I've been rattling away for quite a bit, but is some of this making sense? Yep, cool. Right. I was going to show you the code, wasn't I? I think I'm going to hop onto my VM, which I can't quite see was. Cool, here we go. Now, I'm interested actually because there are some people in the room who's, can you all see that okay? Is that a bit too small? Is it okay? Yeah. There's some people in the room with Terraform experience. How do you do it? Do you have a specific way that you work? Because I speak to some very clever people, much more clever than I am, who do a lot of this stuff, and they say, well, it depends. If it works, it works. You know, how do you structure your files? Do you use modules? Do you all have it in the root? You know, how do you do that? Opinions, or it depends, or if it works, it works. Is that the kind of thing?
Depends. I mean, I do a lot of modules, so
Yeah.
every user.
Yeah.
So if I'm just quickly writing something,
Yeah.
depends what you're doing today.
Yeah, sure. No, I wanted to, again, I'm not a Terraform expert, but I use Terraform for my own benefit to do stuff like this. But I wanted to get to the module stage where I can, you know, selectively choose what I want to do and then point a module and deploy that. I think, but it seemed to be a huge amount of effort when I could just do it this way. I think the effort would be worth it in the long run.
That's the thing. It's worth it in the end.
Yeah.
First time.
Sure. Cool. That's good to hear because I'm just keeping myself sane here because I live in an office. I very rarely get out of the house. It's great to be out this evening. So it's not often you actually get to talk to people with opinions and, you know, real world situations. I actually long to go back to an office because I generally felt working in an office, there's a certain amount of osmosis that happens where you just absorb stuff around you, and I can feel my skills all disappearing. You know, but doing stuff like this really helps because it challenges me and gets me out of the house. Yeah. So the way I've got this structured as well is you'll see it's all within the GitHub repo. Even the presentation showing up is in there. What I've done as well with the Linux host is, if I just find the machine, where's the machines? So VMs here. So as part of the machine creation in Azure, I'll find it. I'm just calling this shell script. And what that is doing, that one's up here. It's just a bit of a help out. It's installing some of the packages. One of the really annoying things I used to find is when you're going to mount a drive, it would always complain that it didn't have the machine name in the host file. So basically that'll go off, install all the packages for you, and that little echo command will write the machine name into the host file, so there's none of this annoying prompt errors that were coming up. Yeah, so the main file itself, I use the main file just to specify the providers and features. I have started putting a few lifecycle things in there as well on other bits, but for this one, it's just that. It's then going to build in the resource groups. Again, it's just my little OCD. I like to separate things out. I have started now doing, for instance, if I'm building a VM, I'll build the resource group in the same file in front of the VM, if you see what I mean, but that's all there. The really cool thing, I think, is to do anything or to manipulate anything you want for your own lab, the TF-vars file. So all the variables I use are blank, they're just placeholders. And then the only file you need to amend to change this to be customized to yourself is this file here. And I've tried to put in just a bit of a steer as to what to do, you know, things like if you don't want to use the side ranges, use your own. If you just want to call names, use your own. All the stuff in here, you know, if you don't want to use Ubuntu, you want to use a different VM SKU or size or different version, just go and change it as you need. So if you want to go and play around with it, it's all here. Even, you know, if you want to have larger volume sizes, everything in there. So that's the only file you would need to edit if you want to go in, or you just push it as it is and see what you get. And the ways, you know, what else are we building? So you got the resource groups, the virtual network. So this is I actually found, sorry, to digress a bit, I found a really neat trick to put that onto one string now and just have like a separate tag file. And you just add the tag file and it will concatenate it onto one string and then create individual tags. So I haven't got around to updating that. I will do, I'll push the update for that. Anyway, I'm quite a fan of Terraform. It's addictive actually for me. It's a great way of doing stuff. So yeah, so in here with the network file, if you're familiar with Azure VNets and constructs, obviously we need to create a virtual network. Within the virtual network, we're specifying obviously the location, everything else, and DNS servers as well. So that's really, really key and important, especially for Azure NetApp Files and building SMB volumes. If an SMB volume fails to build, it's either network issues or DNS issues or both. So make sure you've got your DNS service configured. And then we're going to build subnet. What I've done in here, I've got subnet 1. I've split the system 1 in 2s. So subnet 1, subnet 2. You call it what you want. But I just did it for simplicity. Subnet 1 is essentially a subnet where the server gets pushed into. The second subnet, subnet 2, that's the important piece, because this is then the delegated access. So it's a delegated subnet for the Azure NetApp File service. If you're familiar with subnet delegation, you need to tell the subnet that has access to that service, and that's how the ANF service gets brought into your infrastructure, into your VNet. I've also, as part of the network layer, created a peering. So what this will do, it will create a VNet in North Europe and a VNet in West Europe, or based on the regions you choose, which you can specify in that TFRs file. But it will pair the regions together, so your network traffic will flow between the two. So if you wanted to, as an example, if I find the volume configuration, volumes. So a release which happened in October last year was at the network features release, which is here. Standard network features. Previous to October last year, it was basic network features, which means you couldn't peer one hop. So if you remember the construct in Azure for VNets, VLANs, we're going to call them, you could go from one VNet to another. You couldn't have a transient, or you couldn't then route. Well, you also couldn't peer globally, so you couldn't go out of region. With the standard network features, you can now have that transient because you can use user-defined routes, which you couldn't before, and you can also have the peering globally. So what you could do, for instance, if you're messing about with this, you could have your Linux host in North Europe and your volume in West Europe, and you could access them across that peer. So that was a feature as part of that as well. Go back to the networks file. VNets. Yeah, it's quite for those who know Terraform, it's quite self-explanatory, and for anybody else, it's a great way just to spin up and play with stuff. We've got Linux machine, so yeah, there's a couple of Linux machines again. Very straightforward configuration, all done by the TFRs file. So if you I know part of my career I worked at a data center which was founded on open source. I was the first Microsoft consultant they hired. I was like the Antichrist. Honestly, nobody talked to me in the technical office for 6 weeks because they just hated the fact that a mouse jockey, as they called it, had appeared within their midst. And they were allowed to they were basically given free reign of the operating system they chose. Some used Gentoo, some used Debian, CentOS. And a week after I joined, a lovely guy joined in the open source team, and he chose to use Ubuntu. Got absolutely berated for it. But what they didn't realize is this particular gentleman was the guy who designed, wrote, and delivered Blue Yonder's mail system. So he was actually a bit of a ninja when it came to coding. But he used Ubuntu. Some people poo-poo it. I don't know. I mean, I just use whatever, to be honest. I use Mac, I use Windows. It doesn't bother me. But if you wanted to use a different Linux distribution, just feel free to find the package and put the one you want in there. Cool. Conscious of time. How am I doing for time? Okay, no worries. Cool. I mean, that's about it, really. Just going to hop back to the presentation quickly and find it. There we go. Cool. Yeah, so very brief overview of Azure NetApp Files, what it is and how you can deploy it. As I said, I think the key things to remember, I think the headline for Azure NetApp Files is simplicity. The efficiency that you can get from doing it by deploying storage to scale it as you need it to get the performance that you need. Obviously, it can help with your cost, and its mobility. You can take applications, solutions that were deployed in the 90s and push them into Azure using file services should you require that. Again, the presentation is going to be on the GitHub repo. There's links here, so to my GitHub repo where you can find all of this. I can share that up with Oscar as well if you wanted to pass it on. Also, a few other links to Azure NetApp Files as the technology, things like architectural best practices, the benchmarks that have been produced for the actual performance of the platform, and things like the replication as well. So get started, go and play with it, see what you think. I mean, I learn by getting my hands dirty. I'm not a theoretical person. You saw earlier, I started my career on a fishing boat, so I'm not very bright, but I can lift heavy things. I learn by playing with things. I learn by getting my hands dirty. And the great thing about Azure is, you can just play with it, spin it up, destroy it. You pay for what you use, and hopefully, if you've got MSDN accounts, you get free sort of £115, I think, per month if you've got an MSDN account to play with. So it shouldn't really cost you any money. And also, there's quite a few free things now that Microsoft do, which you can sign up for, and you can just consume them for free. But the great thing about it is, especially if you're using IAC methods, is you can spin it up quickly, and you can destroy it quickly as well. Cool.